Greetings and welcome, friends. Mr. Wada here. We were talking about areas of polygons. We talked about rhombuses and kites. And one of the things we had discovered that the area of a kite or rhombus can be found by taking half d1 times d2, right? So here it looks like I could call this d1 is equal to 6. But the question is, how do I find this diagonal? Negative. 5 plus 5 would be the long way around. But these are right triangles. If this is 6, then what's this length? 3. And therefore, immediately you guys know what this length is. It's 4 because that's a Pythagorean triple. Hooray! Hooray, guys! So here's 4, right, Lauren? So what is the entire diagonal across, Lauren? What is this entire distance across? Is 8, right. So now D2 is going to equal 8, Isaiah. So area is going to equal half of 6 times 8. So that's 3 times 8, or 24 units squared, U squared, right? Multiplication is commutative, so it does not. It does not. Okay, this was a little interesting. Find the measure of angle GJH. GJH is the grande angle. I know none of these angles, guys. How can I find this? It's a central angle. How many sides are there here? N is equal to 8. So I could do 360 divided by 8. And what is that, 45 degrees? Okay, so there we go. So if that entire angle is 45, then question, what would GJK be? GJK, which is just this angle here. Half of 45. So that's going to be 22.5 degrees. And we end up needing that sort of concept later on in finding the area of regular polygons, because we end up having to deal with these right triangles, Lauren and Joshua, right? We've got to possibly even use some sines and cosines a little later. So let's find out. Let's jump right in. Here's question 20. Find the area of the regular polygon. Now, I'm going to draw this little triangle right here and blow it up. Go back. What's up? What's your question? Isaiah, no thank you. No thank you. So, one of the things you should do is, yeah, mine's not at all to scale. This is 90 degrees. I need to find the apothem here, which is A. I currently know the radius is 10, and I know that this entire distance across S, the side length, is 6.84. So I'm going to need some additional information. Let's start by counting how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's the name of a nine-sided polygon, Malik? Nonagon. So n is equal to 9. How could I find the measure of the central angle, Malik? 360 divided by 9. What's that, 40 degrees? Right, so 40 is the entire angle. Question, I don't need that. I need this angle. So that's going to be 20. And so from this 20-degree angle's perspective, the apothem is the adjacent leg, and the radius is the hypotenuse. Hi. No. Joshua, question, comment. Yeah, the relationship between the adjacent and the hypotenuse is cosine. So I'm going to say cos cosine of 20 degrees is going to equal the adjacent, which happens to be the apothem, both labeled A conveniently, divided by the hypotenuse, which is the radius of my nonagon. And so A is going to equal 10 times the cosine of 20 degrees, and I can get a decimale approximation of that. So 10 times cos 20, right? That is going to be 9.397. So Lauren, this is the apothem. I'm trying to find the area. What was the area formula, Lauren, for what's the... Yeah, how do I find... What's the area formula? Someone help her out. One half of the area, the apothem times the perimeter, or the perimeter is the same as, I could rewrite perimeter as the number of sides, n, right? And the side length, s, because the number of sides times the side length is the same as the perimeter. So it's half the answer. So, I currently know that, so let's plug in. So the area is going to equal half the apothem, 9.397, times the number of sides multiplied by the side length, 6.84. Right, Lauren, Malik, you're like not even looking the right direction, man. 0.5 times 9.397 times n, 9 times 6 point... Here, just a second. I've got to focus while I'm typing. Let's see. I get A is approximately 289.24 units squared. What was your question, Joshua? Correct. There's no distribution when all multiplication is taking place. Yep. So there we go. So that's how you find it. Let's see. I'm not going to take the time to do this whole problem, but could someone walk me through the approach? Isaiah, tell me how I would do this. And Eliza, check this out. This is good stuff. Okay, so you could find the perimeter by... Okay. So what's that? Like, is that the 42 one? Yeah. All right, that sounds right. Yeah. So there's the apothem. Here's my radius. All right, so 360 divided by 6. Your central angle is 60 degrees. And then half of that central angle is... Well, what's this distance? Yeah, half of that would be 3.5. And cosine? All right, because I've got, if I want to think about these, I've got the adjacent, I've got the hypotenuse, and I've got the opposite. The thing that I currently know is the opposite. And I need both, or I need the apothem. I just need the apothem. Ooh, I actually didn't need the radius for this. But how could I find the apothem here? What compares opposite to adjacent? That would be tangent, yeah. I could find r, and then you could use Pythagorean theorem between those two sides to find the other one. So I'm going to say tangent of 30 degrees is equal to 3.5 over the adjacent. And so then A times tan of 30, right, Malik, is equal to 3.5. And therefore, A is going to be whatever 3.5 divided by tan 30 is. We didn't end up needing the radius. Yeah. But yeah, so you'd find that, and then you'd do the half app sort of thing. We already got the perimeter. So thanks for watching, internet friends. Have a great day.